Hello kids again. In this case, we are going to try to review our chapter 5 information for having a better study material for our exam. In this case, chemical reactions. Matter is often described by its characteristics or properties and how it changes, right? The two kinds of properties of matter are physical properties and chemical properties. A physical property is a characteristic of a substance that can be observed without changing the substance into another substance. The temperature for melting a solid metal is, for example, a physical property. Color, texture, density, and conductivity are physical properties of matter. A chemical property is a characteristic of a substance that describes its ability to change into another substance. To observe the chemical properties of a substance, it must change or be changed into another substance. A chemical property can be a material's flammability or its ability to rust or tarnish. Changes in matter can be described in terms of physical changes and chemical changes. A physical change is any change that alters the form or appearance of the substance but does not change it into another substance. A change in matter that produces one or more new substances is a chemical change or a chemical reaction. In a chemical change, the atoms rearrange to form new substances. When a substance undergoes a chemical change, it results in different physical properties as well. Substances that undergo chemical changes are called reactants, and the new substances that form are going to be called the products. Chemical changes occur when existing bonds break and new bonds form. New substances are produced. Chemical reactions involve changes in properties and changes in energy that you can observe. One way to detect chemical reactions is to observe changes in physical properties of materials. For instance, the formation of a precipitate, uh, gas production, and a color change, as you may see on the pictures on this slide, are possible evidence that a chemical reaction has taken place. A chemical reaction, for instance, occurs when atom bonds break and new bonds form. Breaking bonds requires energy, right? While forming bonds releases energy. In an exothermic reaction, remember that energy is being released as the product's form is greater than the energy required to break the bonds of the reactants. The energy is usually released as heat. In an endothermic reaction, more energy is required to break the bonds of the reactants than is released by the formation of the products. So, when energy is absorbed, the surroundings become cooler. Remember this because it's very important for you to understand uh, chemical changes happening here. Okay, and the last lesson that we're going to be talking about, in this case for chapter number 5, lesson number 2, you can find it on your books on page 170. In this case, we're talking about describing chemical reactions. Three main objectives to accomplish are identify the information included in a chemical equation, explain how mass is conserved during a chemical reaction, and we are going to try to identify three categories of chemical reactions. So if we are going to be trying to answer the question of what information does a chemical equation contain, well, first of all, let me tell you that a chemical equation is a way to show a chemical reaction. using formulas and other symbols instead of words. The formula of a compound identifies the elements in the compound and the ratio in which the atoms of ions combine. A chemical equation tells you the substances you start with, in this case the reactants, as you may see on the image over here, in a reaction, and the substances that are formed at the end, the products. The formulas for the reactants are written on the left, followed by an arrow, which is read as yields. The formulas for the products are written to the right of the arrow. Plus signs are used to separate two or more reactants or products. And simple as that, you have a chemical equation. In this case, you can see an image of a chemical equation, which first was considered to be a chemical reaction. So this has to be related with balancing chemical equations, right? Something that you are very much experts doing this, right? So basically, we are going to be trying to answer the second question. How is mass conserved during a chemical reaction? In a chemical reaction, all of the atoms present at the start or at the beginning of the reaction are present at the end of the reaction as well. Atoms are neither created nor destroyed. They are just rearranged to form one or more new substances. This principle is called the law of conservation of mass. All chemical reactions must obey this law. If a reaction takes place in an open system, for example, matter can enter from or escape to the surroundings. In a closed system, matter does not enter or leave. To obey the law of conservation of mass, a chemical equation must be balanced. And it's exactly what you are seeing on this picture over here. It must be balanced by showing the same number of atoms of each element on both sides of the equation. To begin, write the correct chemical formulas for both the reactants and the products, and then you're going to be counting the number of atoms of each element on each side of the equation. You are going to use coefficients, which are the numbers placed in front of a chemical formula in an equation, and then you're going to check that the equation is balanced. And finally, we have three types of chemical reactions. These types of chemical reactions are synthesis, decomposition, and replacement. In a synthesis reaction, two or more elements or compounds combine to form a more complex substance. A decomposition reactions occur when compounds break down into simpler products. In a replacement reaction, one element replaces another element in a compound. This is called single replacement, or when two elements in different compounds trade places. And this is going to be known as double replacement reactions. So then you have plenty of information to study for your third bimester exam. Hope to see you soon, kids. I really miss you a lot. Bye-bye.